All right, I guess we'll get started right on time today. Hello, everyone. My name is Kyle. This is my second time at NDC Oslo. My first time was on this exact same stage 2 years ago. I'm very excited to be back. Before we get started, I want to get an idea of my audience today. So can we get a quick show of hands of who would call themselves infrastructure engineers or DevOps with an infrastructure kind of focus? What do we got? Okay, so that's about a third. All right, which is cool, because that means the rest of you are here just because you find this stuff interesting, even if it's not directly relevant to what you're building. And that is great, because that's what we need in this field. We need everyone to have some interest in how we can improve security, because it's not just about the infrastructure side, it's about the people who are developing the applications that interface with it as well. So we're talking about how to build a passwordless cloud architecture. And what I mean by that is, say you're using AWS or Google Cloud or Azure, any of these, you can build an end-to-end system that, from the employee point of view, the developer, the engineer, et cetera, who are actually setting this up, you don't need a password anywhere in your infrastructure whatsoever. A bit of background about me. I did my PhD at the Massachusetts Institute of Technology, which I finished in 2018. And I actually focused on aerospace engineering and human systems integration, which is the field of research of how you develop technological systems for the end user to be able to use it effectively and safely without breaking it or themselves. And that doesn't seem super relevant, but when we start talking about passwords, that's a very human thing. That is very much relevant to human factors engineering in this, and the psychology of it, and how people choose their passwords and use them and reuse them, add a 1 at the end when it expires, etc. So it is quite a relevant field. And I did my work in the Computer Science and Artificial Intelligence Lab, which is this goofy-looking building, but actually has some really cool stuff going on inside. And then after I finished that, I started my own company, Invicton Labs, focusing on a lot of cloud and IoT-type solutions. And we're based in the lovely city of Ottawa, which is the national capital of Canada. Come check it out. Just like Norway, it's much nicer in the summer. Be honest with yourselves. Who's seen this before? This is incredibly common, way more than we like to admit. This is why passwords are bad, among many other reasons. Let's define what is a password for the purposes of this talk, because there are variants of this definition, but for this talk, we will define a password as any kind of value that is used to authenticate or authorize someone. It's provided to the authentication system as is, so it itself is not encrypted when a person types it in. And it's used to, or it can be something that is used to generate or derive a value that is used as a password. So that's like your SRP protocol. And this includes a lot of things that we might not always consider. Of course, you have your classic passwords, API keys, one-time tokens that have a long shelf life, SMS or email one-time passwords, so those magic links that Slack loves to send you, or unprotected certificates. Those are private keys that are not password protected. And passwords can leak in a lot of different ways. We all know that, but let's kind of review some of the ways that can happen. There's always the question of plan versus reality. We all want to use vaults. We want to use rotation. We want to use two-factor authentication, require complex passwords. People don't actually do that. We can try to enforce it, but the end user will choose whatever is most convenient for them. In our case here, what we're talking about today, the end user is the developer who is trying to use this infrastructure that we've set up for them. They're going to choose whatever is most convenient, and that is just human nature. There isn't a whole lot we can do about that. You can set policies and threats of enforcement and action and all that, but realistically, it's not reliable. Passwords leak in a lot of ways. We talked about plain text, very common. Every client I've worked for has done something like this along the way. CI/CD breaches. I'm sure you've probably heard of some of these. CodeCov. This occurred in January of 2021. It wasn't discovered until April of 2021, several months later. 29,000 clients affected, including HashiCorp, Mozilla, Twilio, and Rapid7, some big names you've probably heard of. Travis CI. They had a breach where by forking a public repository, you were able to print out some files in the build pipeline and get the original repository secrets, even though you forked it and it's not yours. Password managers, great solution. This solves all of our problems because they are secure. They're not always secure. This is a CVE from KeepPass. It was writing passwords in plain text to the system log. LastPass, probably heard about this one. This one got a lot more media coverage. They had their development environment breached. Now, they say that's not an issue because it's only development data, which is somewhat true, right? Because in theory, none of their actual clients are having their data in the development environment if they're not copying the production database to use in development. But when you can get access into development, you can start injecting things that can then get promoted into prod, and there are all sorts of security issues there as well. What about not revoking old credentials? Mike was fired from our company because of some gross negligence, bad conduct, whatever. We fired him. Nobody revoked his credentials, which means that he can still log in. He still has an AWS access key and secret, and can do whatever he wants, and no one's paying attention to that. Incredibly common. And when I say something is common, that is just personal experience of working with dozens of clients over the last few years and seeing these things in practice across many different companies. Credentials that are locally stored but not rotated. Anyone who works with AWS will probably recognize this. This is a credentials file that has long-lived credentials that are not linked to a specific user. They're just a key that gives you access to an AWS IAM user. For someone like myself who works with a bunch of different companies in an administrator type role, this file, if I used this, could have admin permissions for 20 different enterprise deployments, and anyone who gets this file could then do anything they want with any of those. Certificates and private keys. Another issue where it is something that is a very long-lived document that is often stored unencrypted on your local device. Anyone who can get access to that now has your password. Of course, we have the ability to guess passwords, which is a form of leaking a password. This is, I think, 2021's results. Hasn't changed much in the past few decades. This, of course, isn't a big deal because developers would never do this. This is for end consumers, right? Enterprise companies would never do something like that. It's incredibly common. When we look at the costs of some of these issues, these things, we start to understand why it's worth investing in security, why it's worth investing in better protection of our infrastructure. When a consumer account is breached, right, my personal email account is breached, that attacker gets access to my data. When my company's database is breached, that attacker gets access to millions of consumers' data. And things start to exponentially increase depending on, as you start getting into some of the very large enterprises. We can see that as we get into some of the larger breaches of 40 to 50 million users like Equifax, we're talking in the $400-ish million to recover from that. And this is, a few years ago with inflation, that's now probably $1 billion. Here's a real life example of that. $500 million for a breach a couple years ago for T-Mobile. That's $350 million for the claims and $150 million that they had to guarantee they would spend on improving their security. $425 million for the Equifax data breach. Do you know how much DevOps time you can get for $425 million to improve your security? I will do that for you. Hire me. And not only that, but you start getting into the political aspect of this too. 50 attorneys general, so the state lead legal authority in the US, came after Equifax for this. So let's talk about the risk of these things happening. Risk we define as the probability of something happening times the impact if it does occur. So we can reduce risk in two ways. We can reduce the probability that it'll happen, and here we can achieve this by using passwords in fewer places, storing the passwords in fewer places, so not keeping them in a text file on my shared drive, using short-lived passwords so that if there is a breach that at least it doesn't last as long. And then we can also reduce the impact if it happens. And we do this by using our principle of least privilege, or known as your minimum permissions model, meaning that we do not allow a credential to have any access to anything that is not absolutely essential. We monitor and detect our breaches so that we can respond very quickly. And we use short-lived passwords again because that reduces the amount of time that they can cause damage with this thing. So in summary, passwords are risky. We really don't want to have to use them if we don't have to. And if we do use them, we want to minimize their scope to ensure that they're as least risky as possible. So what are our alternatives to passwords? We really have 5 kind of factors that we can use for authentication. Right? We have your knowledge, which is knowing a password. We have something you possess. That's your MFA device, your security key, something along those lines. Inherent to the user, that's biometrics. Your location, which could be in the computer world, usually our only option there is an IP address. And behavior. Behavior is an interesting one. That could be something along the lines of Jack usually works 8 a.m. to 4 p.m. Someone is logging in with Jack's account at midnight. Maybe we block that attack or that login attempt because that does not match Jack's behavior. Unfortunately, in the modern world, every employee wants to do this and work remotely from a beach in the Bahamas. So we can't really use your location anymore. It's simply not a realistic option. You can do things like VPNs, which kind of adds a layer, but even to log in with your VPN, as we'll talk about later, that usually requires a password of some sort, so it's not helping. So instead, for our passwordless design, we're going to, conventionally, for a two-factor system, you'd use knowledge and something you have, right, possession, your 2FA phone, key, etc. We're trying to get rid of the password, so we're going to get rid of that, and instead we're going to add something inherent, which is your biometrics, fingerprints, Face ID, something along those lines. Now this is expanding, right? This is something that is not brand new. It's been around for quite a while, this concept of biometric systems combined with possession. So WebAuthn, the whole FIDO Alliance and everything they've worked on, security keys, Max Touch ID and Face ID, we're really starting to see some expansion and adoption in those fields, which is great. So let's focus in on FIDO though, because that's really the golden standard today and what all of the larger companies are moving to support. So we kind of had a couple different versions of FIDO throughout the years. First, we started with FIDO U2F. That was multi-factor authentication only. It was a system that allowed you to use something like a security key as your second factor. You still had to have a password as your primary factor, though. And it replaced your one-time password. So instead of having that time-based one-time password, that number that showed up on your phone, and typing that in, you could instead use your security key and tap that with your thumb and use that instead. It was neat, didn't really solve a lot of issues though, because in most respects it wasn't a whole lot of improvement over your traditional time-based one-time password. And then comes along your FIDO UAF and FIDO2, which we commonly know as WebAuthn. And this is where we start introducing biometric authentication as your primary authentication mechanism. So this starts getting very interesting because now we can use this to replace the password. It is now the primary system. FIDO UAF kind of didn't really get picked up. It was part of the earlier standards. There was a lot of infighting between different groups in the committees that the different large companies that were trying to be represented and how they wanted to implement it. You know how fun it is to try to get Google and Apple to agree on something, and then Microsoft sitting there and be like, I don't care what either of you think. So that didn't really get picked up. But then FIDO2 comes along quite a few years later, and it now has common standards that are agreed to by all the giant corporations. There's a lot of confusion about the terminology that are used in these systems. So this is a little diagram just to kind of clarify it best we can. So WebAuthn is an API, and that gets a lot of confusion. It is not an API that your server offers. It is an API that is exposed in the client, in the browser, for the JavaScript to use. You had CTAP, Client to Authenticator Protocol. This is the other half of FIDO2, WebAuthn and CTAP, and it's a system that allows me to use a different device to log in. So say my phone has my FIDO2 WebAuthn key on it. I want to log in on my laptop. I have those things connected by Bluetooth or NFC. I can have my phone here, my laptop here. I can log in, and it will pull the key off of my phone. That is CTAP2. And then FIDO is the whole FIDO authentication process is the actual client-to-server system that uses WebAuthn and optionally CTAP if you're trying to use a key on a different device. Adoption. So the initial FIDO U2F and UAF proposal was 2014, didn't really get picked up because end users do not like carrying around extra things, so they don't want to carry around a security key. They didn't really have support for biometrics, and developers are lazy, so you still needed a password. But then FIDO2 starts coming along, 2018, and here you have that complete replacement for passwords, built-in fingerprint and face recognition into a lot of laptops and phones. Windows Hello, Apple Touch ID, Face ID, all these cool technologies with these fancy consumer-facing names. This is just FIDO2. You start to get better smartphone support, which is really the key in that end of that decade to getting user adoption. And we can see kind of in the graph here, the adoption over time of how this started to get picked up as a topic of interest. Who's heard of a passkey? Yes. Okay, so this really highlights the point. A passkey is a FIDO2 Web Authent key. It's the same thing. It is rebranded by Google and Apple as something that consumers are more likely to understand or enjoy the sound of. Like, it's a marketing term. But it is a FIDO2 key. And it also kind of, it's not really part of the standard, but what they've done is they've implemented a multi-device system for it, so where you can store your key instead of in a trusted platform module or something physical on a device, you can store it in your browser that actually syncs across your Google account and all the different things you're logged into, or your Apple account. So I can create a key on my Android phone, and as long as my Chrome browser on my laptop is logged into the same account, I can use those passkeys interchangeably on the two devices. There are pros and cons of that. Clearly, storing things in software is not as secure as storing it in a trusted platform module or some unbreakable physical device, but it does offer that user friendliness, which has really helped with the adoption. They didn't set it up for enterprise users. You can sign up for passkeys as a personal user, but for the corporation side of things, where we might want to use it for infrastructure, if we're using Google Workspace as our federated identity provider, you can't do it yet. By the way, if you click that link about find out more, it takes you to this page which says you can't do it. Doesn't really tell you much more. That'll probably be coming sometime this year, early next year, but unfortunately it's not available yet. But we'll talk more about that in a bit. And we start to actually see this being picked up for end users. GitHub allows you to use a FIDO2 Web Authent key for your second factor authentication, and then various applications and websites are starting to support Apple passkeys and Google passkeys, and hopefully with how hard these companies are pushing it, this will become ubiquitous. So now we've kind of given the background. We're going to talk about a traditional architecture that you might use in a cloud deployment, because we've been focusing more on the consumer side of things, but now we're talking about us and what we're building. Different components that you'd find in the majority of different systems. So we're going to start with an identity manager, right? Your federated identity provider usually includes an email service, so Outlook, Gmail, etc. Includes authentication system, which traditionally is logging in with a email and password. Hopefully it requires 2FA. Everyone should require 2FA. 22% of companies require 2FA. It's still being picked up. This is a year ago, so it's probably a bit higher now, but it's not great, and there's really no reason not to do it. Reduces your threat vector by about 95 to 98% by doing that. So definitely use 2FA. And in your cloud system, you're going to have some sort of user credentials. So here we have a long-lived AWS access key, which is connected to an IAM user. They have very expansive permissions most of the time. This is not something you have to do, but realistically, when someone's creating these keys, it's a pain to go in, and if you've ever worked with AWS permissions, it's quite annoying to try to get a minimum set that works for specifically what you're trying to do. So generally use a star, admin, everything access to these, which is not great for our least privilege model. They're stored locally. Like I showed you in that file, it's a text file on your laptop that just stays there, and anyone, if you leave your laptop logged in, could grab that. We're going to have a VPN because we want to improve our network security. Problem is, a VPN usually requires a username and password or a certificate, both of which are long-lived secrets. Most organizations don't handle certificate revocation properly. I've worked with quite a few, and I have never seen one actually set up in an effective manner that handles certificate revocation. What do you do when someone gets fired but they still have that certificate on their device? It's actually rather complicated to set up a system for that that works across multiple different cloud services. We're going to have a password, a database, and a password for our user in the database. Now, database passwords can be rotated, but realistically, they're probably not, because that's just more work to set up, and we're trying to get something quickly out the door, right? They're long-lived secrets because they're not being rotated. And often a single user is shared across many different applications or different microservices, or however you're structuring your architecture, because that's easier than trying to create a bunch of different users with, again, those minimum permissions, which are a pain to keep maintained. We're going to have some code repositories. We'll use GitHub in our example here, and a CI/CD configuration in there. Now, logging into this, long-lived credentials, that's a username and password, that are often outside the organization's control. When you're using a service like GitHub, unless you have their expensive enterprise plan, which most companies don't, even the enterprises. I worked for the federal government of Canada. They didn't have an enterprise plan. And that means that you're linking their personal accounts into your corporate account, your corporate organization, which means you do not have a whole lot of control over their personal account. You can set some requirements like 2FA, but there isn't much more than that. Now, these credentials are often much more sensitive than they're considered to be, because the ability to push code, even if it's just to a development branch or an environment other than production, that allows you to get something in there that, if you cleverly hide it, will get promoted through into production, even if you do not have access to production yourself. That is quite a significant risk vector. Also, having full access to your CI/CD pipeline is fairly high risk as well, because you're working with a lot of secrets. You are using something that does probably push something out to production, and that's a risk there. In your CI/CD system itself, you have secrets, usually. We'll talk about this. Long-lived secrets, because these are a pain to rotate, and most places I've seen, these are several years old, usually by the time I get in there. And it's easy to leak them through workflows and pipelines, and we saw an example where something that was completely unintentional, like a breach happened, right, where they were able to get these credentials from a forked version of a public repository. But even without that breach, it is easy for a malicious actor who has internal access to be able to get things that are not designed for them. So someone in development, if it's not configured properly, can get secrets for production. And usually these credentials have pretty extensive permissions for the same reason we talked about earlier, where it's a pain to use a minimum permissions model, so we don't, right? So these are most likely usually admin ** permissions for your cloud service. They're relatively hard to rotate, because when you start to need to integrate different systems, GitHub with your AWS Secrets Manager and some piece of software that generates new credentials and rotates them, etc., that is a bit tricky, and so we just don't do it. And so these are rarely rotated. Now, I'm not saying, hopefully some people in this room are saying, we do that, but not everyone in this room is saying that, I'll guarantee. Also, they're relatively hard to trace, because when you have automated systems that are doing things on their own without a human logging in and making it happen, it becomes quite a bit trickier to track down where this originated. And so we hear that's just how it is. We don't really have a lot of options. My whole point here, which I hope you've picked up on by now, is that that's how it used to be, and we do have much better options. A couple core principles about how we're developing these things. One, we want a single source of truth. In this case, that's going to be about our identity provider. We want one place where our users are managed, our groups are managed, and from there, we can use that to authenticate against other systems. We do not have user accounts duplicated in various places. We want to use group-based permissions instead of individual user permissions, which makes it much easier to maintain that least permissions model and to make sure that everyone's permissions are always up to date. And we want passwordless everything. I guarantee you that through here there will be no passwords in what we're talking about in that entire infrastructure. So we're going to go through that entire design again, and we're going to look at how we can do all of those same things without requiring any passwords. So for our identity manager, we're going to use Azure Active Directory. I've chosen Azure because as of today, they are one of the only ones that provides a passwordless login method. As we looked at, Google Workspace is rolling that out with passkeys. Google is rolling it out with passkeys, but Google Workspaces does not yet offer it. Hopefully that's coming soon. So they have passwordless authentication for your end users. In this case, our end users are us and our developers. And that supports fingerprints, FIDO devices, face recognition, whatever kind of biometrics you want to use for that. And this provides our needs for email, calendar, etc. Hopefully this is coming this year. They're not fully transparent about when that's going to be released. They didn't initially. They said everything was going to be released this year, and then only later did we find out that workspaces was not included. For AWS, we're going to create an IAM identity provider with SAML or OIDC. And what this allows us to do is use our Azure AD as our identity provider or as an external identity provider for AWS. And so we can create roles that have trust policies for IDP groups. And that's essentially saying that this is AWS terminology, but it applies across all the different clouds with different names. We say that this role can be assumed by someone from this identity provider who has this group. And that allows us to create role-based permissions or group-based permissions. Generally, this is an IDP-initiated flow. So from Google Workspace, you'd have a panel where you click this button and it takes you to AWS with your Google account or your Azure account. And this allows us to have passwordless users, because you can log into Azure without a password, who now have passwordless access to AWS. And we've eliminated those long-lived AWS security keys on our device. Another option is Identity Center SSO, Identity Center, which formerly was known as AWS SSO. It's essentially a wrapper for an IAM identity provider with IAM roles. It offers a pretty interface to go with it. It has pros and cons. It does duplicate the users in an internal database, and it's kind of a pain to sync between the two, but it's another option if you're interested. Offers a much improved UI, and it does offer the service provider initiated login, which means you can go to the AWS page, log in, it redirects you to Azure, and then takes you back instead of the other way around. But it requires the user and group provisioning and a synchronization, which they have very poor support for as of now. For our VPN, we're going to use an AWS VPN client. So this is based on OpenVPN, but it's modified a little bit for AWS-specific client VPNs. And we can link it with our IAM identity provider, meaning that when you go to start your VPN, it opens up a browser, takes you to the AWS login page, redirects you to the Azure login page, use your biometric login, redirects you back, and now you have a VPN connection. You didn't need a password. And you can do some cool things with that. You can configure the authorization rules, which are which network segments and subnets you're allowed to access on that VPN, and link that to user groups. So you can say that someone in the front-end developers user group can access these subnets, someone in infrastructure can access the production subnets, etc. And you can configure that entirely based on group-based permissions. So now our VPN access is passwordless, and it's linked to our group-based model. For our database, we're going to use Amazon's RDS service, Relational Database Service. Here you can set up IAM authentication, which means that it uses AWS's IAM service, Identity and Access Management service, to control logging in as database users. You can limit which database users an IAM user can log in as based on IAM policies, which we showed earlier can be linked to Identity Center or different roles for different pieces of software. So you can say that this user is able to log in as this database user through that IAM policy. If you link it to Identity Center, that again is connected to our Azure Active Directory, and now we have our developers able to log into the database with this entire passwordless system using their Azure user groups. It does require short-lived tokens, so when you log into the database, it generates a short-lived token that you use as the actual password to the database, which is unfortunate that that exists, but it is only a couple minutes that it survives, so it's not a major risk. One of the downsides here, if you're dealing with this, is because that short-lived token has such a short lifetime, if you're using this in a long-running application, you have to generate dynamic connection strings that use a different password every time you log in, which is totally doable. It's just a little bit of work. For repositories, we're going to use GitHub Enterprise because it supports SSO through SAML. We can link it to Azure Active Directory. So now our repository and our CI/CD access is based on our Azure groups. Azure was passwordless login to GitHub. Now this one is my favorite because I think it's probably one of the least known about, but also the most useful. So we're going to use GitHub Actions for our CI/CD process. And instead of storing secrets in environment variables that are accessible through the build process, we're instead going to generate, in our build process, we're going to generate a GitHub signed web token. And this is essentially a JWT that includes all the metadata about the job that's running, right? Branch, repository, organization, commit, hash, etc. And GitHub signs that and says, yes, this we guarantee is legit. And what we can do is we can integrate that with an IAM OpenID Connect provider, OIDC provider. And we set up an OIDC provider in IAM that says we trust GitHub's JSON web keys, and any key that comes in that's signed by them, we will believe to be accurate. And now, using this provider, we can create IAM roles with trust policies that are linked to some of that metadata that we talked about. So we can say that we're going to have a role called backend deployment development, and that role can be assumed by any GitHub action that is running on the repository with this name, on the development branch, and all these different parameters. And that allows you to have very specific permissions that don't require any passwords and that can't really leak because that JWT is very briefly lived and has to be signed by GitHub. So now your GitHub hosted runner can assume an AWS IAM role, which it can use to do those deployments, did not require a password, does not require any secrets in GitHub whatsoever. If you're interested in this and you understand Terraform, I created a provider that can do this in a very simple manner, which I used as a demo for a previous talk, but it's available. I use it in production deployments, and it really shows how this actually works at a lower level. So in summary, we have our identity user management, we have a VPN, we have databases, we have code repositories, CI/CD system, not a single password to be found anywhere in that infrastructure. So we've really achieved our objective, right? We have been able to set this up without any passwords. There are a few limitations you will come across as this is still a relatively young technology that is being gradually adopted. But it's totally doable, and most of these I use in every production deployment that I set up for every client. I want to talk a little bit about selecting vendors, because we've talked about GitHub and Azure and AWS and these different service providers that we choose between. There is an ongoing conflict of interest in this situation that can be difficult to deal with. There are some things we want to look for in all the vendors we select. First off, we need SSO support. OIDC or SAML, either or. OIDC is preferred as a modern standard, but SAML works just fine. This allows us to use a federated identity provider to access that service. We want something that supports role or group-based permissions instead of individual user permissions for reasons we discussed previously. And we want a provider that thinks it's important to provide security-based features at no extra cost. Security, in my mind, is a shared responsibility. It is our responsibility to use technologies that are effective at building a secure system. And it is our vendors' responsibility to provide security features to incentivize us to use security features without having to pay through the nose for an enterprise platform for it. Things we want to avoid: no SSO support, user-based permissions, services that charge a premium for security services, essentially the opposite. Let's talk about some examples. A couple of things to note on here. Terraform Cloud, I love Terraform. I use it all the time. I've tried a bunch of different infrastructure as code providers, and I just keep coming back to it. Terraform Cloud is not open source. It's kind of the privatized hosting version from HashiCorp, and you have to pay for it. Team management is a paid feature. So they have a free version, but on the free version, you can only create administrators. You cannot have any user with a lower level of permission than full administrator access. In order to be able to control those permissions more effectively, you have to go to the paid plan. If you want to use SSO support, you have to go into the enterprise business plan. And if anyone's ever seen this little button down here and clicked it, you know that's a button you don't want to have to click. These things get very expensive, and this is an incredibly common thing to do, is to put SSO in the enterprise custom pricing package because only enterprises want to use that, and it's a feature only they care about. That's the line I've heard from everyone I challenge about their pricing model, but it's not true, right? Anyone with a 10-person company that wants to set this up, of course SSO is a good idea. You don't need a giant corporation for it. Get rid of your passwords if you can. There's actually a website, and I can't remember what it's called. It's like basically a public shaming board that lists all the different companies that have SSO as an enterprise feature. When there's no other option, always want to use 2FA. If we have to use a password, at least please use 2FA. Drastically reduces the risk of compromise, of a breach if that password is compromised. Rotate your passwords. This seems like a lot of work, but once you get the hang of it, it's really not that big of a deal. Various password vaults and managers have tools built in to help you with this, like AWS Secrets Manager has built-in rotation capability for a lot of different services. You have to pay for it, or you can just roll your own. Use randomly generated passwords, of course, and keep those tokens for external services, so API keys, etc., in vaults that are only accessible by the applications that need them, not by every employee in your company. And also try to have them loaded at runtime and not stored in environment variables, because that really does help ease the burden of rotating them and not having to update all of your deployments in your architecture. If a password does have to be shared across multiple users, some login that is a shared account of some sort, of course, use a password manager. They have their flaws. They've had some breaches, but it's still a heck of a lot better than the alternative of not using them. Limitations of biometric authentication. I don't want to give you the idea this is perfect and that there aren't any issues with it, because it's better, but there still are. You can clone someone's fingerprints using various pieces or various materials like silicon and such. It's not super feasible, or like it's not going to be a common thing because you still need physical access to the person you're trying to attack, which is relatively uncommon in our world where most of our breaches come from overseas or some other country on the other side of the world. But it can still be done. So the other thing is that the Face ID can also be hacked, kind of. So they usually use an infrared image of at least several frames, and they try to do a three-dimensional model of it. This has been circumvented. It has been patched since then, but it was Microsoft's Windows Hello that was circumvented by using a single still frame from an IR camera that was captured of someone in an elevator, I think. And they were able to log into their account with that. It's improved a bit, but it's still, again, can be breached. It's not perfect. But what do we do about this? Well, why not both? Why not everything? There's no reason that if for something that is extraordinarily sensitive, you can't use biometrics and password and physical device and yada, 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 which I have patented as Extreme Auth. Mine, don't take this. You're going to take a fingerprint on device A for your WebAuthn, and that is going to unlock your device, which has a security key, and that is going to now move you to device B, where you will do Face ID to unlock a different security. Now on device C, you have to enter a password or a PIN, also through WebAuthn, which supports passwords and PINs. This is going to then allow you to receive an email confirmation code. You click that, you get an SMS confirmation code, you type in a security question with your code, and voila, you've logged in. It's a ridiculous example, but you can chain these together however you want. You can build whatever deployment or configuration is best for you and your company and your end users. This would be a very secure system, right? You would need multiple different devices and knowledge and behavioral patterns and so on, but it would be a huge pain in the ass to log in with. So this really demonstrates kind of the balance between security versus user friendliness. FIDO2's pass keys offer a great balance between those two in my mind. They're very user-friendly. They're even easier than passwords. You don't have to remember anything. All you need to do is have your device and some way to unlock it. So I highly encourage you to consider that as a new option for your new builds, as a way to upgrade your existing builds and make your systems far more secure. Thank you very much. That is all I have here, but I'm happy to take questions about any individual aspects of this or ideas or suggestions about how we might implement this in various systems. no questions. Okay. Well, thank you very much.